Hello everyone, my name is Illarion and I'm going to talk about Virtual DOM and how we can use it with any JS framework, app, or as a standalone concept. Virtual DOM, let me start with a meme. Okay. What if I told you that Virtual DOM does not equal React? Well, that might not come as a surprise for you, because Virtual DOM is a concept that was made popular by React. So it's a separate concept that allows us to work with our entire application UI as a whole, re-rendering the entire scheme. I think you like React. Most of you, all of you heard about it. Most of you like it, but only some of you use it because it's hard to transform your legacy application into this new shiny React form when you have a lot of code that is running in production already. So that's the same situation that I have at work. So we have a lot of e-commerce store that would greatly benefit from React in Virtual DOM, not in React. In Virtual DOM, in some areas of the website or the app, but we cannot re-implement it in React without spending too much time and money. So I began researching how can I use the Virtual DOM, the advantages of Virtual DOM, without buying into the entire React thing. And I've stumbled on a Virtual DOM library. It's literally called Virtual DOM with a dash. And the author of Virtual DOM has summed up nicely the entire concept. A Virtual DOM is nice because it lets us write our code as if we were re-rendering the entire scene. Sorry. So I stumbled on it and thought, that's the thing that I want. I don't need to buy into any JS framework to use Virtual DOM, and it has a lot of advantages. Virtual DOM allows us to use a declarative way of representing the DOM. So basically, we define our app UI as a model. We can simply say it as a JSON model and pass it to Virtual DOM, and it will update our UI when we need to change something. We simply pass the new state of the app. So if some switches have been switched on, switched off, fields were updated, it will all render magically, well, almost magically. I'm sure many of you will agree that we don't like magic. And this way allows us to have a clean and maintainable rendering logic. So we don't need to update anything manually, and we have a clear way, a clear path of updates. And that even allows us to render views on client and on server. Well, I'm sure you use handlebars, for example, on the server and other templating engines, but here we can pass even hooks from the server, the event listeners. I will talk a bit more about it later. One more thing that I've stumbled on and I'm contemplating on using it, I'm telling you from the start, I haven't tried it yet, but you can move UI calculation to a separate thread into a web worker and achieve true parallel computing in the browser. And one of the most important things for me was that we can write a better test for the UI, because we are working with a model. If the one model is correct, it will render nicely. And it is replicatable in the test. So, as you can see, Virtual DOM has a lot of advantages. And it has a lot of implementations. First of all, React, as you might think. And then goes Virtual DOM, the one that I use. Mithril, it's a framework. You can use it instead of React. It's a virtual DOM concept plus a lot of nifty extras. And the last three are libraries too. The maquette library promises us that we can use animation inside virtual DOM. But I haven't tried it yet too. And the last two, VDOM and Inferno, promise us the fastest implementations of the virtual DOM. Mind you, this comes with a drawback. If you decide to try them out, please read the documentation because there are quite subtle differences in what they render, and they cache a lot of things, and you might not want that. Okay. I've borrowed a slide from Henrik Joretek from his pocket-sized JS talk, and I highly recommend you to watch it. And here he compares the file sizes. Then if we use React, the original zipped file size is 146 kilobyte. It's zipped already, and it's a bit too much for almost any application, unless you have a huge UI built into your application. While virtual DOM zipped is only 14 kilobytes. So you have saved almost 10 times the size. And it supplies all that we need. File size for me is important too because I work in e-commerce and we have a huge overhead of images. Images trump everything in a store. You load 10 or more images and you would like to spare just a couple of kilobytes for your own JS, JS file, but you know that you need to load it as fast as possible before loading images. And all of my clients think it's a priority to load the images first, but the store doesn't work the beautiful way as they think without my file. So I have to save everything that I can. Plus, you need to take JS parsing and calculation into account. So if you load a huge JS file, even if you have a fast connection, the browser needs to evaluate it. Even if it doesn't execute most of it, for example, if the function returns early, it still needs to evaluate it. And this is doubly important on small and slow devices like Windows phones. Well, I have a Windows phone and I like it. What? Okay. Yes, yes. Yes, it's in my opinion, Windows phones have the most beautiful and elegant UI, the Metro UI. Yeah, you might not agree with me. The ecosystem is really small. It's ridiculously small, I agree. So here we have come to a practical example of how we can use the virtual DOM library without React, without any framework, with jQuery to build an auto-updating cart widget. Cart widget that saves that saves file sizes, that saves time and of execution and processing time. Okay, if you can see, we have in a cart we have items that we would like to buy. So here we have 3 items. Each block represents an item. And here we have quantity buttons, the total price of this item, and an X that signifies the remove button. And we have a total at the bottom. So when a server sends us a new information, for example, a user added a new item to the cart, the total will update and the new item block will be drawn here. We could use jQuery as a minimal method to manually add this element to the cart and track the additions and removals and the updates manually in different functions. But that's not an efficient way. Virtual DOM allows us to render the entire cart widget every time we get an update. So the server simply sends us a new JSON file with the cart data, the cart contents. And Virtual DOM will re-render the entire thing smoothly and efficiently. So here how it looks if we use Virtual DOM library. First, we need to declare 3 dependencies from the library. One note, though, you have to use Browserify to gain advantage of this library. So you need to precompile it. It might be a turn-off for some of you, but it's the way to go. Anyway, if you were to use React, you would have to use Browserify most likely too. So we have a div, patch, and create element. And we have our own render module, and I will talk about it later. So the initial render. Let's assume that the initial render is empty, so we don't have any data from the server, and so we don't have items. So the initial tree receives an object with an empty array for items. And it renders an empty cart widget. Then we create an element that will be updated whenever the tree is updated. So we create a variable root node and assign it, call the function create element with the tree that we've rendered just before. And later we attach it to the place we want it to be in our document. And here's where updates happen. The update widget is called every time we receive new data from the server. So in this example, I've used a global custom event by jQuery. So whenever this event store cart fires on the document, the update widget function is called. That's why we have EVT variable first, and then the payload, the cart data. And here inside this function, we declare new tree, and we call render with the new data. This is where the state is changed. And then we calculate the patches. We diff the tree, the old tree here, from the new tree. And then we patch the main element. This might not look as functional for some of you as it is. It's not, but it works. And to be fair, it works the same way in React. So we cannot achieve true functional programming Zen everywhere. Okay. So and then we assign the new tree to the old tree variable to save it. So this variable is updated every time to store the updated render. And it goes around and around and around every time this event fires, essentially every time the server sends us new data. And what I like about this scheme is that it's really transparent. You know where you declare what, and you know the way you update your state and essentially your app or widget. Okay, so this is the render function itself. It uses virtual hyperscript. It's a special language for creating virtual trees, much like JSX. But unlike JSX, it's pure JS. So it's functions inside functions and arrays and objects. So it is lintable. You can check if it's correct. And it's pretty much concise if you compare to the two other implementations. So this is the function. As you can see, we pass the card that we receive from the server, and we render it as follows. This H represents the virtual DOM hyperscript. And here we declare properties and attributes, and then we pass an array of children that we are going to have in our widget. And I like this too. So we can use native JavaScript functions here. So I've used a map from Lodash to map the card items into the final elements of the tree that I need. So each item is converted into a div element card items with item title, item price, updated respectively, and a button that allows us to remove the item. I've intentionally omitted the update quantity buttons to simplify the example. And as you can see here, an important detail, if you decide to try out virtual DOM and the hyperscript, I would like to turn your attention that we declare properties, HTML properties of the element directly, like type, class name, and so on. And if we need custom attributes like data item line, I've included it for convenience. From my experience, you need such attributes when you work on cards. Yeah. And here, so we need to declare static attributes. Unlike properties, we need to declare them inside attributes. So, and we have a class that we are going to use as a hook for the event listener. And this is all. The entire widget will be rendered using this function. And it's testable, pretty much. It's lintable, and it's concise. So now we would like to activate our buttons. So I will focus on the remove button, but as you can see, the activation of quantity increments and decrements buttons is straightforward enough as well. So we use jQuery to bind an event listener to click event on JS item remove class and call the function. This way we create delegate event listeners. So they will be attached to the widget itself, and the events from our remove buttons will bubble up to the main events. What this means, you can read more in jQuery documentation if you are not familiar with this concept. But basically this means the elements may not exist at the time we declare the event listener. So since the first time when the cart widget is rendered, it's empty, we can create a delegated event listener, and it will attach automatically later. Well, To be precise, it will not attach. It attaches only once. And this is actually a more efficient way to deal with multiple events. So basically, this is it. So of course, the server does all the grunt work. We send the updates to it. It sends the card data back to us. And in my opinion, this is great. I like thin clients. I don't like bloated apps that do too much themselves. Anyway, the data belongs to the server in a store because we need to check out later. And we cannot store it in the app. This minimal logic allows us to create a complete cart widget that is updated nicely, automatically, and preserves computing time. I will not show examples of before and after here. You can run the test yourselves on real things, but it works, as React has taught us. It really works. Okay, so we have around 20 lines of code here and around 12 here, and this is all we need to make it work. Well, okay, 5 here more. Where can you read about virtual DOM? In its documentations, it's not that easy if you're not familiar with the concept at all. But please take your time, and you will have a powerful instrument in your hands to make it work. If you would like to have something more similar to React but lighter, I will really recommend Mercury framework. The creator of Mercury has decided to use Virtual DOM library and actually contributes a lot to the Virtual DOM library. So you can safely use it if you'd like to work it. Also, I've included links to the questions that I had, to the answers to the questions that I had when I was considering using it. So, first one, can we serialize VDOM patches to pass them as messages to a web worker? Because web worker accepts strings and JSON objects in some implementation. A string is a safe bet. So can we serialize it? Yes, we can. And if you follow this link, you will find extensive info about it. Can we render virtual DOM as a string for server-side use? Yes, we do. And there is a library for that. And can we revitalize the existing DOM? For example, if we have rendered VDOM on the server, then passed it as initial state, can we use it as initial state for our tree? Yes, we can. We can init virtual tree from the existing DOM on the page using the library that you can find through this link. And a bit more about web workers. In a UI, it's a miracle because we can actually you can do this in React as well. I would urge you to read on about it because you can move almost all calculations into a separate thread and making your main thread as light as possible. And this the benefit is double or triple on smartphones because most of them have multiple slow cores, and this increased the performance of the app significantly. I'm going to try it myself in the next few months, and I'm sure I will send you a report if you'd like on the WarsawJS page. Okay, this is it. Do you have any questions?
Brawa, brawa. Tak jak Illarion powiedział, czy są jakieś pytania, czy czyjaś? Proszę bardzo.
Nie, jeśli chcesz dokończyć, to
dokończyć. Czy po prostu się dowiedzieliście wszystkiego, czego chcieliście, czego oczekiwaliście od tej prelekcji? Czy są jakieś pytania dotyczące Virtual DOM-a, Reacta? Śmiało zadawajcie. Pamiętajcie, przypominam, że zapomniałem powiedzieć przy moim poprzednim wejściu, że mam 2 koszulki do rozdania, więc dla tych najbardziej aktywnych będą 2 koszulki. Znaczy, będą po jednej koszulce.
Okay, I would like to just point out that it's possible to use JSX without React. Actually, it's not JSX. It's you probably know it, but for the others, so it's probably actually to use JSX with any virtual DOM implementation. You need just to set right pragma. This is the parameter for your Webpack plugin for transpiling JSX into JavaScript. And in your case, when you are using h script and the h function, it will be pragma set to h string, and it will work just like that.
Yes, I agree. I know that we can use JSX separately from React, but JSX is not virtual DOM itself. So you can render any template using JSX. And the thing is, I don't like JSX.
Okay, but I can't say I don't like it either, but I like it. But it is the big business value in JSX, because I'm not the only who will be edit my code. Maybe the designer would like to change the icon, and I don't want to be bug about change the icon. When the designer has the basic knowledge about HTML, he can be confident doing this by himself. He's not aware it's something different than HTML, but he will be able to do that without bugging me about it. So I consider this as big business value of JSX.
I know this is a popular opinion among managers, that we can save the human workforce and essentially save money by sharing roles. It is my personal opinion that it's a bad idea. Eventually you will find a situation, yourself in a situation on Saturday night when your designer has decided to change something and changed a lot of things. And you would have to go to work on your Saturday night. I had this experience myself, and I need to say that this is my personal opinion. I think the developers' work and designers' work should be separate. If designers want to change something, they need to assign a task to the developer. Going back to JSX, the reason that I don't like it is because of the same reason. Because it mixes basically strings, even compiled later into real JavaScript code. It mixes strings with JS code, making it pretty much untestable, unlintable. Well, you can name it.
I can agree. It makes it untestable, because that's what we said later. It's the same. It's actually it doesn't influence any way you test your code.
Did you say the style?
You used to say about strings, and
yeah.
it just like really, because would you like to be bug about your designer to change some minor things? And I can.
In fact, I did.
Okay, so
because
I
control the situation. I control the code.
I also can say, okay, you're right, because someone can break. No, it won't, because we have continuous integration with end-to-end test, with unit test, and if he make a typo and the build will fail, I will be noticed about that, and I don't have to fix it right now, right?
Yes, I agree that modern technology exists to catch this kinds of errors. We have continuous integrations. We have other stuff that takes care of it. But the truth is, many companies do not have them and do not plan to implement them. And as a conscious developer, especially, I'm working for a company that provides a finished product to our clients, and they take care of maintenance later on. And they may not decide to. They may not use continuous development and other nifty tools, And in the end, we will be held responsible if their designer later breaks something. So it is my personal opinion, and it's my safe bet that it's better to separate things like JSX and JS, to separate designers from developers. Well, designer can be the developer, but if there are two people, they should be separate. Yes, I would like to urge somebody else to ask questions about Virtual DOM, because this conversation was about the templating engine.
Tak jak Illarion powiedział, czy są jeszcze pytania? O, tam na końcu, dobra.
So basically, it's kind of like curses library does the refreshing of the screen.
Yes, you can say that. Yes, curses would be a good example. I'm not sure that everyone is familiar with it. I can even say that I don't know how curses work.
Yeah, I mean the basic difference, if you have a terminal app and you would like to do something fancy, basically you need to clear the whole screen and redraw everything. But if you use curses, you can define what the next sort of frame should look like, and then the curses will calculate the difference and apply it kind of like a virtual DOM, if I understood it correctly.
Yes, an excellent example.
Okay.
You see, all the good technologies come from the 70s.
Yeah, great minds think alike. Thanks.
Jeszcze jakieś pytanka? Czy czyjaś ciekawość nie została zaspokojona, to chciałem powiedzieć wcześniej.
So my general idea was to show you that you can use this highly beneficial concept of virtual DOM with any JS framework or no framework, if you like. So you don't have to stick with React if you need to make your app response performant and small.
Dobra, brawa, brawa, brawa.
Thank you.